Okay, so we've got the diagram, the laminate, and it's in bold as well, removing a circle, the centre P, from the rectangle ABCD, and adding a right angle triangle XYZ. So I've got a double thickness where the triangle is, and I've got a hole where the circle is. And then, so what we got, we've got the shapes. We've got a rectangle, the big rectangle. I need the circle and the triangle, and then finally, what I got left by cutting that circle out and adding the triangle in. So the rectangle is a 20 by 18 rectangle. So the amount of area that I've got is 20 times 18, which is 360. And the centre of gravity is at the centre of that rectangle, which is 10 across, 9 up. So the coordinates, taking A as the origin, okay, the coordinates then of the centre of gravity of the rectangle is 10, 9. The circle tells me the area of the circle is 21, so I don't need to make a calculation. So I've got an area of 21, and the centre of gravity, again, taking A as the origin, I'm going across 6, and then I'm going up, right, the 6 down, 18 all the way, so I'm then going up 12. The triangle, that's a 12 by 6 triangle, so the area is 12 times 6 divided by 2. That's 72, half 72 is 36. And the centre of gravity of the triangle, from that corner there, it's a third along to the right. So it's 2 along there, and it's a third of 12 up, so it's a 4 up there. But I got to do it in relation to the origin here at A. So to get to X, it was 11 across and another 2. So that means I'm having to go 13 across, and then to go up, it's 3 up already, and I'm going another 4. So I'm going 7 up. So there's the coordinate of where the centre of gravity of the triangle is. And then the area of the whole amount I got is 360, take away 21, add 36. 360, take away 21, add 36. That's 375. So we combine 375, and that's at my X bar, Y bar. So I dealt with all the complicated diagram. I've now got a simple masses at these coordinates. Okay, and so all we have to do when I put these in to multiply going across is remember how the shape was formed. So it's 360 times 10. I've taken the circle out, so I subtract 21 times 6. I've added the triangle in, so that's add 36 times 13, and then I need to divide by the total mass 375 to get X bar. And I follow the same pattern for Y bar. I start with the rectangle, so it's 360 times 9. I'm on the Y coordinates now. I'm taking out the circle, so I subtract 21 times 12. I'm adding in the triangle 36 times 7, dividing by total mass that we got, which is 375, and that equals Y bar. And then it's just a calculation. Safest way to do it on the calculator is to use the fraction button, type the top line in the top box, bottom line in the bottom box, and press equals. Okay, and those answers, X bar is 10.512 and the Y bar is 8.64. Okay, that's the first 10 marks. Right? And then second part says when the laminar is suspended freely from a point Q on DC, okay, so I'm hanging it somewhere along DC. It hangs in equilibrium with DC making an angle of 45 with the vertical. So if I just simplify the diagram now, basically I got a rectangle shape. I don't need to fill in all the bits and pieces of the other shapes. Okay, and what I've found out so far now, the position of centre of gravity is there, which was 10.512 across and 8.64 up. Okay, and the whole side is 20 and that's 18. Now then, what it's telling me is that the angle, when I suspend from somewhere on this line here, DC makes an angle of 45 degrees with the vertical. So let's say I suspend it there, say, call that Q. Then if I suspend it in there, that line there is the vertical. And what it's telling me that DC with the vertical makes an angle of 45. And I want to find how far Q is. I want that length there. So if I look in this right angle triangle here, what I want that distance there, the adjacent. Okay, now then, I can calculate that length of the triangle because I know it's 18 all the way down, it's 8.64. So if I take 8.64 from 18, I get 9.36. So that length there is 9.36. So now I can calculate that length. I can either use trigonometry, the tan ratio, or because that's 45 degrees and it's a right angle triangle, this is actually an isosceles triangle. So if that's 9.36, that length across there is 9.36. Yeah, because it's isosceles. So distance of Q from D is 10.512 all the way across. That part is 9.36. So that length there is 10.512 take away 9.36. That's 1.152. It says find the possible values. Okay, possible values. Now then, I can also get an angle of 45 if I bring it over and suspend it there, say. Okay, now that is down my vertical, and that there is 45 degrees. Okay, yeah. So, and again, because this is 45 degrees 90, it's an isosceles triangle. That there is 9.36. So another point is when Q is that far away from D, which is 9.36 add 10.512. and that's 19.872. So there's two possible answers.